Welcome back to our series on the analysis of practices, social representations and behaviors in Socio-Hydro systems. Understanding the preferences of stakeholders for the environment, anticipating their responses to new technologies, services, policies or programs remains a challenge. This is because policies are established in complex and dynamic contexts, and a great diversity of stakeholders is involved. Stated preference methods can enhance our ability to evaluate these preferences with approaches like contingent valuation and discrete choice experiments. In this video, we'll focus on discrete choice experiments. Discrete choice experiments help us understand how people select options based on their preferences when presented with a finite set of hypothetical choices.
Imagine a community deciding on a project of restoration of the local river. Right now, the river is channelized with little vegetation along its banks. The area is therefore exposed to flooding, it has limited biodiversity, and no direct access to the river for recreation. The City Council is exploring ways to improve the riverfront, but with limited budget. They therefore need to make careful choices about which features to prioritize in the project. Should they give priority to green, biodiverse areas or to being a walking path? Each option, keeping the current state or moving forward with the restoration project, therefore has different characteristics. The cost of the project, environmental benefits, potential for recreation, and flooding risks. In discrete choice experiment, we assume each person has specific preferences for these characteristics. That can be modeled in economic terms by a utility function. For instance, a person who values highly biodiversity and environmental health might support a restoration project that includes a wide vegetation buffer. On the other hand, someone interested in recreation might prioritize adding a walking path. Lastly, a cost-conscious individual might prefer to keep things as they are. These choices among alternative projects can reveal these utility functions and highlight the community's diverse preferences and priorities. The City Council wishes to consider these preferences to design the restoration project that satisfies most residents. The objective of the discrete choice experiment is precisely to estimate these preferences.
To understand people's preferences, we conduct a survey during which respondents are presented with several choice cards. Each choice card presents a set of hypothetical scenarios called alternatives. Each alternative is described by specific characteristics called attributes, such as biodiversity, environmental health, recreation, and flood risk reduction. There is also a monetary attribute, typically representing a price or cost associated with each option. Each attribute can take on different levels. Each alternative offers a distinct combination of attribute levels. Typically, respondents choose between two new alternatives and a status quo, which they can select if they are not interested in the proposed new alternatives. When respondents look at these choice cards, they select one option based on the attributes presented. This choice reveals some information about their preferences, since the alternative provides a different mix of attribute levels. To gather enough information about respondents' preferences, we present several choice cards, each showing different scenarios. This approach allows us to thoroughly assess the trade-offs people make between various attributes. For meaningful results, we need a carefully crafted experimental design to ensure the options represent a full spectrum of potential preferences and trade-offs. This design is crucial for capturing reliable insights into what people value most. By analyzing their choices, we gain insights into the relative importance of each attribute. The analysis of trade-offs between the monetary attribute and other non-monetary attributes such as biodiversity, flood risk reduction, allows us to calculate what is called the willingness to pay, which indicates how much respondents are willing to pay for specific non-monetary attributes. The relative importance of each attribute may vary from one person to another. This is referred to as preference heterogeneity. This helps policymakers design programs that better align with community values.
At Precos, our goal is to facilitate the co-construction of public policies with stakeholders involved in the management of socio-hydro systems. In particular, we use these methods to estimate the value of ecosystem services generated by a public policy intervention and to identify individual factors that influence the demand for these services, or to estimate the influence of the characteristics of water policy instruments on stakeholder participation. Our primary focus is on examining the diversity of preferences, underlying motivations, attitudes, and decision-making processes, rather than concentrating solely on estimating monetary values. Specific issues arise when applying stated preference methods to socio-hydro systems, such as respondent unfamiliarity with the services generated by the project, complexity due to multiple uses and scales, uncertainties in policy outcomes, multiplicity of stakeholders with different views, and potential non-monetary reasoning. Here are two examples of discrete choice experiments we've conducted. In Bordeaux, we estimated that households were willing to pay 179 euros per year for 60% reduction in high heat zones, obtained with the development of green infrastructure. This value can be used in the cost-benefit analysis of an investment project to verify whether this monetary benefit may outweigh its cost. We also found that individuals more exposed to heat waves have a higher willingness to pay than others. This allows for the creation of a demand map for this service and can support discussions on the spatial deployment of these techniques in the city. In Laos, we identified that maize growers use a diversity of choice process not compatible with standard economic theory when they select agricultural practices. For example, some farmers consider only the attribute labor constraint to make their choices due to hard constraint on this resource. These findings offer insights on the real decision rules followed by farmers. It should help crop system developers to effectively promote the adoption of technologies.
In the upcoming videos, we will present specific examples of how these methods are applied to socio-hydro systems. We hope you found this video informative. For more insights, follow our series on the Precos webpage and on our YouTube channel. For questions or feedback, please contact us using the information provided on screen